Great talk by Eric there about EIDs and how we can do some approaches that are more agnostic of the different credential that was used regardless of the bank ID provider. And we're going to build on that talk now, where we will dive deep into what that OAuth spec is, and then we will finish up with a bit of information about OpenID Connect, which will actually segue into Paul Mattson's talk right after this. So the talks are going to keep building on each other. And you've probably all gathered this by now, but my name is Travis Spencer, and I'm the CEO of Twobo Technologies. Twobo Technologies is one of the organizers and one of the founders of Nordic APIs. So thanks for coming to my talk, and we'll go ahead and jump in here now. Before going into all of the details, I just want to kind of step back and put this in a bit of context, where the API security is part of a bigger picture of providing safe and secure access to information that organizations are exposing and different clients are consuming. And the API security is part of that. The other important sort of tenets or facets of that are enterprise security, keeping those servers safe, keeping the enterprise itself secure, and mobile security, where the clients running on those endpoints are secured. And these three together are the primary concerns that we have to be considering, and the broader context of the situation. And if you kind of put those together into a Venn diagram, and I'm sure Paul will have a few of these, so I'm trying to set up for him. Right in the middle of all of that is digital identity. If you look at enterprise security, mobile security, API security, knowing who somebody is step one. If you don't know who somebody is, how can you answer the question of what are they allowed to do? So as we look at all of this, keeping in mind and knowing who someone is critically important. And we're talking about web APIs here at this conference, and we talked some about REST and SOAP, and how SOAP is really giving way to REST. We need to have some technology, some tools in our tool belt for actually securing these APIs. And the way in which we do this is by using the suite or collection of different security standards that provide us with that information about who somebody is, so that we can decide what they're allowed to do. And this is made up of what we call the neo-security stack. So we need to have some capabilities of actually federating that identity by figuring out who somebody is in one context and passing that to another, like Eric was talking about. And this comes to us with technologies like SAML and OpenID Connect. For provisioning, actually creating user accounts, removing user accounts, we use an open standard called SCIM, which Eric will talk about in more detail tomorrow. And then for identity and actually knowing who that person is and having a digital representation of that, this stack uses an up-and-coming protocol that's called the JSON Identity Suite, which I'll touch on. And then for delegated access, we have OAuth. And then finally, for authorization, we have XACML. Tomorrow in my keynote, I'll talk about how you can use this stack to build secure API platforms. But for now, I want to talk only about OAuth. OAuth 2, there are multiple versions of this, but the one that most of the conversation and discussion is around today is around OAuth 2. And this is really a meta protocol, or a protocol of protocols. It's being used to create other sorts of message exchange flows, some of which we'll talk about later, like OpenID Connect, but even others like UMA, which you may have heard of. And the novelty and the speciality of this protocol is that it can be composed in all of these useful ways. It's a sort of framework. OAuth 2 allows us to address both old requirements that we had, but also some new ones. And maybe not new use cases. We definitely had delegated access requirements before, but the way in which it's implemented, which you'll see, it makes it very easy to solve that problem. So the actors that you have in OAuth are these. You have a client. So the client is going to be something like a website or a mobile application. And then you're going to have a resource server, which could be like your API, and then you're going to have the authorization server. So this is the web service that actually issues the tokens. You can sometimes hear of this called a security token service. And then, of course, you have the resource owner or the end user. In OAuth, we have something called scopes. Scopes are like permissions or rights that a particular client wants to gain. It wants a resource owner or a user to authorize it to do certain things. What these things are is communicated between these actors using scopes. These can be anything you want. They're not defined in the standard. The standard just says it needs to be space-separated list. So you're free to create any number of scopes you want. And the way this often manifests itself is in this consent screen like Eric showed you in his talk. Do you authorize this application to do these particular things on your behalf? What's interesting as well is that you, as a client, you might have a mobile application, you might have a website that wants to do these certain things. A user might come over and see like, well, I don't want to actually allow this application to do all these things on my behalf. It could ask the security token service or the authorization server to issue only a token that allows for a certain subset of those scopes. There are various kinds of tokens. Eric talked a little bit about refresh tokens. There's also access tokens. If it helps think about it, an access token is like a session. Just like you go and you log into a website and for a time you're there, you have this active session, you don't have to re-authenticate. But after that time period ends or a certain amount of inactivity has transpired, you need to create a new session. You need to jumpstart that again. And you can do that with the refresh token. And that refresh token is like a password where you can get a new sort of session, a new access token. And the access tokens are used solely for invoking APIs. They should, whereas the refresh token should never be sent to the API. The refresh tokens are for sending to the security token service to get new sessions, new access tokens. There are different ways of passing these tokens around. The two that you need to be aware of are passing a token by value and another one of passing it by reference. So what I mean by that is when you take a token, because OAuth doesn't actually define the token format, you can have any token type you want. By value means all the information about the end user is in the token itself. There's some sort of digital signature over that to ensure that it's not changed or compromised or tampered with. But then there's the by reference, which would just be some sort of pointer into the actual data, some sort of reference to it. So in that way, the client or the API rather would have to submit that reference to get back the user data. So pointer versus the actual information within the token. There are different profiles of tokens. So you have bearer tokens. Bearer tokens are kind of like cash. If I find some money on the street, I can pick that money up and I can take it to a business and spend it. And they're not going to ask me for my identification. It has the issuer on there, and that's good enough for the store or the merchant that I'm transacting with. And so that information is not tied to any particular holder. It's just simply the possessor of that currency, that money that allows the person to spend it. On the other hand, there are types of tokens which are called holder of key, where you actually tie the holder to the token, so that if I give somebody else that token, they can't spend it because it wasn't issued for them. So different security profiles and principles around those different things. So you have to kind of decide, do I want something more like cash, or do I need something more like a credit card where I have to ask for identification as it's presented? There are various types of tokens, as I mentioned. It's not standardized in the OAuth spec what sort of tokens could be issued by an authorization server. So you could have, in fact, WS security tokens, you could have SAML tokens, you could have JSON web tokens, you could have custom homegrown tokens, you could have something based on an EID perhaps by hashing it with that. All sorts of different things that you can do. You can use web access management systems that you have, like Oracle or SiteMinder or whatever, to issue tokens. And this actually provides for simplified integration in some cases where you might have applications that need a cookie or a token from one of those web access managers. And by issuing it through an OAuth server, you get a standard flow with your client and a standards-based integration to third parties, but you don't have to update, or hopefully not update much, your existing systems. So I've mentioned now a few times the JSON protocol suite. What this is a collection of different standards. These are all being ratified within the IEEE, the IETF. And these are for defining tokens like JWT, which is pronounced like the English word jot. There's also other definitions in this suite for things like keys and algorithms, encryption, signing. There's also a specification that says how to take a bare jot token and bind that into OAuth so that you can request authorization based on those jot tokens. So let's dig into the jot tokens a little bit. These are sort of lightweight tokens. The idea here is that they will be passed in HTTP headers and query strings over 3G networks or bandwidth constrained networks. So they're intended to be quite lightweight, but you can think of them, if it helps, like SAML tokens, where they have information about the end user in them, like attributes or how that user was authenticated, at what time they were authenticated, those sorts of things that you find in SAML tokens, but they are less expressive. They're encoded as JSON rather than XML. They're much more compact. And so in that way, more targeted at the scenarios we find ourselves dealing with today in mobile devices and Internet of Things. So let's walk through this flow. So in this, there are various flows in OAuth, and I'll only show a code flow, which is the one Eric was talking about. Tomorrow we'll do a demo with the client being a mobile app. But suppose you have a website and some sort of browser client and a backend API and an OAuth authorization server. So this website wants to call this API on behalf of this resource owner, this end user application. So what happens is that request to be authorized causes the web browser to be redirected up to this OAuth authorization server. So at this point, like Eric was saying, you could log in any which way you want. How you do that is not defined by the spec. It just says you must be authenticated. So this actually provides you a great number of options at this point about how to figure out who that end user is. After you've done so, what happens is the OAuth authorization server, at least in this code flow, sends over a one-time usage nonce, or not more than once, code that the client, in this case a website, now has and must quickly redeem because these are very short-lived. So that code is sent on the back channel. So this is all going through the browser in redirects. But right here, this thing just makes an HTTP call. Passes that code up to the authorization server. There, the authorization server authenticates this client. So it has some sort of credential to show who it is. This is a confidential client. And then what comes back in this request is an access token and potentially a refresh token, a session, and a password, so to say. So now once it has that access token and that refresh token possibly, what it submits is only ever the access token, right? So the refresh token always stays with the client. The access token is submitted up to the API. At this point, what's interesting is that the API, if it's by reference token, right, it doesn't have any information about the end user in that token, so it might need to be dereferenced. Who is that end user? Makes this back channel call, gets that information. If it's a buy value token, it can just create a compute a digital signature, verify it, possibly decrypt it. But then at that point, it has information about who that end user is. Not only does it have information about who this end user is, it has information about who this client is. And it has information about who this issuer is. So now we can actually do some very, very important authorization checks. Should you be able to access the data that you requested when doing so on this entity's behalf, or this entity's behalf? That four-party trust model is something we always wanted to do with WS Star. I mean, there is support for this in protocols like WS Trust. Very, very complicated. If you ever looked into act as, that's what this is, act as in WS Trust. But this is just, it was so hard to do in that spec, and it's the opposite here. It's so hard not to do. So I'll get to this in a little bit as well, but keep in mind that this thing could return an error at this point, right? It doesn't have to just say, well, you authorized it, so therefore, here's the data. It could stop processing. But in any case, it returns some message to the client, and the client then can do those things on the user's behalf, potentially, and return that. So let's look at how this is. We've got some sort of application here. This is asking to be authorized. So we click some sort of authorized button, maybe in the website, maybe in a mobile app. And here we come to the authorization server. We need to log in at some point or somehow to show it who we are so that it can actually be authorized to do things on that other entity's behalf, on that resource owner's behalf. So after proving its identity, after the end user consents to that third party granting access to that, the result in a mobile application, like Eric was showing with the custom scheme, is we need to get access, or we need to get the mobile app back into the picture. So in this case, you would use a custom scheme, and that would bring that mobile application to the forefront to be able to start processing. So in your OAuth server, you would register a callback where you use that custom scheme. That's going to bring that control to that native app. And so then it's going to receive that access code. It would exchange that access code for an access token and a refresh token. This is done by giving a client ID and that client's secret so that it can authenticate itself, gets those tokens back. And you specify in here that your response should be a token. And at that point, then you'll have that password and that session, that access token and that refresh token. So I mentioned, I kind of skimmed over this, but that API has that access token, which gives it information about the client, the resource owner, and the authorization server. It doesn't necessarily need to respond with the data itself. So OAuth is not simply authorizing access. It's not about authentication, as I mentioned. So what is it? It's really delegation. If I would have been the one who named it, I would have called it Delegation rather than OAuth. To maybe kind of help see how that differentiates, think about a business owner who might have an assistant, and that business owner might say to the assistant, I authorize you to go and pull money out of the business account at the bank. And then when the assistant goes to the bank teller might say, well, the business owner said you could do this, but it's not sufficient for my level of comfort to release this data to you. So the business owner and the assistant need to go down to the bank, sign some papers, show some identity. At that point, the bank would decide the assistant is authorized to pull this money out of the business account. So even though you might authenticate the assistant, the bank teller might know who that assistant is, might see that the assistant frequently deposits money into the account, which could be allowed. But the authorization is insufficient in that case. So these things are definitely different And we need to keep in mind when designing systems and when defining APIs that we would be doing delegation with OAuth, but we would not necessarily be doing authorization. So now I want to kind of change gears. I talked a little bit at the beginning about how OAuth is sort of this meta protocol, or this protocol of protocols where we can define other flows and exchanges on that. And one of the most popular that's been built on top of OAuth 2 is a protocol called OpenID Connect. This is a protocol for doing federation. It's a protocol for authenticating a user in one domain and then propagating that identity to another domain. It adds identity inputs and outputs into the OAuth flow so that that client doesn't just receive an opaque encrypted token or a reference token that it can't see into, but it actually receives information about who that end user is, at least maybe with a subject identifier, maybe with a information about how they authenticated and when they authenticated. Also important to know that OpenID Connect and prior versions of OpenID are really only related in name. The protocols are substantially different, and they're not backward compatible in any way. A client in OAuth is often referred to as a relying party in OpenID Connect, just because in OpenID Connect, or in OpenID 2, it was called a relying party. Now the terminology gets a little more muddled with OpenID Connect, so you'll often hear people talk about a client or relying party. They are the same thing. The tokens, at least for the ID tokens, are JOT tokens, so how that user authenticated, the subject, the information about it that's returned from the token endpoint will be a JOT token. This user info endpoint that's defined in the OpenID Connect spec is sort of like a user discovery endpoint and a token endpoint, where you can take an access token, send it over to this endpoint, get information back about the user, like their email address, their postal address, or maybe additional tokens, which you can call to other APIs. So let's go through that flow. So you can see that you have some sort of relying party or some sort of client in the OAuth speak. It will send over that same sort of flow, but one of the scopes that it will include is this OpenID scope. And now user will authenticate as before. That requirement doesn't change, but how it's done is up to this identity provider. That access code is sent over to the relying party, and then that access code is sent up to the OpenID provider, and what comes back is an access token and an ID token. So that ID token is what the client can peer into. It's not opaque. It is actually meant to be consumed by the client, whereas the access token is not. That access token, what we can do after checking that ID token and that it really is intended to be consumed and received by that relying party, what we can do with that access token is we can call this user info endpoint. This access token will allow for only the information to be released as was in the scopes. So if we specify in the original request, we want not only profile information, but email information. If the user authorized that client to have that information, the result of that user info endpoint will be those attributes, the email address, the profile, this sort of thing that the client has been authorized to consume. So as I mentioned, the ID token is meant for the client. The access token is for the APIs. The ID token provides this client with information not only about the user, which I mentioned, but the client. So it knows that it's really for it. And this is very important because, as I mentioned, access tokens are like cash. You can pick them up off the ground and spend them somewhere else. This ID token, since it specifies the specific relying party, the relying party is expected to look into that and see, is this my identifier? Is this really intended for me, or should I not accept it? The username will be in there as well, so that when you actually call into that user info endpoint and you get the results back, you can compare that and see, is the one who authenticated the one whose data this is being returned from the user info endpoint, to provide that connection and ensure that what you're consuming is correct. It will give you information potentially about what the credential strength was, or the credential type that was used during the authentication, the issuer, and the expiration type of that identity token, which could be then correlated to a session that could be created at that relying party. So I mentioned that the request that's sent to the authorization server, or the OpenID provider, will include some some additional scopes. The ones that are defined in the OpenID Connect spec are OpenID, which must be sent, but you can also send profile, email, address, and phone. The email could be a verified email if the OpenID provider has gone through those links, so that the relying party will know that has actually been checked to some extent. I already mentioned that this user info endpoint, you can think about this as a sort of token issuance endpoint. So here, what you could be returning is not just things like email address or telephone number. It could be other access tokens. So here's a collection of 5 other tokens that you can then call into these different APIs to do different things with that the identity provider, the OpenID provider, might be exposing. The authentication to that endpoint is done with a bearer token, with an OAuth authorization token. And the output does depend on the authorized scopes. And like I mentioned, you need to make sure that that subject matches in the output of the user info endpoint with what's in the ID token. So at that point, I'll open it up for questions. Yeah, Matt.
So I'm interested in the in OAuth 2, you have the access token, and that can be by value or by reference. Mm-hmm. And if I understand correctly, the by value kind of has all the information in the token already. How, in that circumstance, how do you handle the user revoking a access token? Is there any
exactly.
way to?
So in that case, the revocation would not be possible to communicate to the client unless you, between the authorization server and the client, establish some sort of communication outside of the spec.
So you just have to deal with it by the lifetime of that token? The
lifetime of that token, or by establishing some back channel communication, so that when the grant is revoked, you can tell that client, throw that by value token away.
Okay, thank you.
Mm-hmm.
That can be an issue for the resource server's cache, the results of that original validation call?
Absolutely. Absolutely. So the question from Paul before he got the mic was, that could still be an issue with by reference if the API is actually caching the results of exchanging that reference for clear text attributes, and not making that by reference call every single time. And in that case, that cache would be out of sync with what's been authorized at the OAuth authorization server. So again, you'd have to send some sort of out-of-band message over to the resource server and say, purge your cache, or like Matt said, just deal with it.
There is work on a revocation spec.
Is there? Okay.
Yep.
Does it have a name?
Revocation?
Not helpful in Google.
No, I think you'll find it.
Okay, thanks. Any other questions? Yeah. Oh.
So in OAuth 1, the default was to sign a request and send that on its way, rather than just to send your own private token around by default, which is not the case in OAuth 2. So aren't you worried about tokens showing up in log files and proxy servers and things like that?
There's definitely concern about where you write your access tokens to, and even more so writing your refresh tokens. There have been cases where that's been mishandled and having some pretty severe consequences. So you definitely need to handle them with care. These are credentials.
I have a very limited knowledge of what was going on there, but there are companies offering OAuth server as a service, and I know that Azure, for example, is bringing that in. When is it a bad idea for a company like ours, who are building an API from scratch, to choose to use an OAuth as a service type company rather than building it ourselves, building the server side of things ourselves?
When is it a bad idea to use OAuth as a service?
To use an OAuth provider as a service. We will, in any case, be using OAuth.
I'd have to give that some thought. I don't want to just make a blanket statement on that.
Can I give an opinion?
Sure.
I would say when you want to maintain control over the identity of the user, you don't want to use it as you don't want to use the server.
I disagree with that, though, because the authorization server doesn't authenticate the user. So your authorization server could federate back to your identity provider. You maintain control of that identity, and it just issues tokens. One issue might be around control of private keys. Do you want that service to have access to private keys that are being used to sign things as you? That could be a potential issue. Paul, thoughts on that or something?
Also, in the absence of a standardized validation call, a SaaS authorization server implies a proprietary mechanism between your APIs and their authorization server.
If using by reference.
Correct.
If
Which
the
is
authorization
now.
server as a service is providing it by value, then you don't create that dependency.
Sure.
Okay, so those are some thoughts.
There was a talk earlier this morning about the developer experience, and for me this is very much the opposite. I know that at our company that we have hard-coded the refresh tokens because no one could get this to work. And I suspect that if you Google, you'll find a lot of refresh tokens at GitHub hard-coded in source code because it's not developer friendly. What are your thoughts on that?
I think that with OAuth 2, a conscious decision was made to make it easier to implement clients and less difficult to implement an authorization server. So now, by changes that were made to the protocol, it's a lot simpler to create a client. But if you actually want to create an authorization server, you have quite a bit of work. And I think what's happened with APIs at the beginning, it was mostly about consumption. We were talking about that, Adam and I, at the pre-event party last night, where at sort of the beginning of the API adoption phase, it was mostly people consuming APIs, so they needed to be OAuth clients. But now more and more are getting into the business of providing APIs. An API provider needs an authorization server, so now the onus falls on them to implement this. Okay, at that, I have to leave it and make way for Paul. So thank you for your time and thanks for listening.